Hello, I would like to welcome you to this Air Traffic Technology International webinar, sponsored by Intersoft Electronics. Today's webinar is titled ATC Surveillance System Testing Using the Radar Environment Simulator. I'm Ben Sampson. I'm the editor of Air Traffic Technology International magazine. I'm going to give you a short introduction, give you some housekeeping notes, and then hand over to the presenters of today's webinar, two representatives from Intersoft Electronics. So, built by Intersoft as a game changer, the RES is designed to overcome the challenges of testing secondary surveillance radar, enhance testing processes, and ensure the highest standards of safety and performance. There is a brochure for the RES to download on the right-hand side of your screen if you want the specs. Also on the right-hand side of the screen is a questions box. If during the presentation you want to ask the presenters a question, then please do enter it in that box. What we're going to do is we're going to save all of those questions up until the end of the presentation, and then I will ask the questions and publish them to view for everyone to view at the same time. So if you enter your question in the box and you don't see it straight away, don't worry, it will come up at the end. Okay, so I will introduce our presenters now. Given the presentation today will be Glenn Bosmans, who is a senior surveillance engineer and the project manager for the RAS portfolio of ATC test equipment at Intersoft. He started his career at Intersoft Electronics in 2009 and became an expert in ATC surveillance test systems. Over the years, he has performed many system performance evaluations and managed the installation and commissioning of sensor monitoring systems all around the world. He contributes his valuable hands-on experience to the development of new test equipment. Second, we have Davey Antonsen, who is a software developer at Intersoft. His interests lie in graphical software development with over 15 years of LabVIEW experience, the main programming environment used for the RAS test and measurement toolset developed by Intersoft Electronics. Davey holds a master's degree in information and communication technology and has developed user interfaces since 2010. In the past 10 years, he has trained customers on how to use the IE/MSSR RES equipment. He also contributes to the technological advances at Intersoft Electronics. For example, important topics related to GUI software development, like using an object-oriented design, is a key factor in his work. So we're lucky to have you two guys here today, Glenn, Davey. Glenn, I'm going to hand over to you now because I believe you're going to start.
Yeah, thank you, Ben. So welcome all to this webinar from both me and Davey. Before we jump into the RES topics, I would like to introduce the Intersoft Electronics group company a little bit for the attendees who are not familiar with us. So we're already active for more than 40 years in the radar market or the radar industry, and we are a reference in radar technology and radar measurement equipment. Currently, our group is structured around three pillars. First one, electronics, where we do all the design and development of modular radar subsystems, which we deliver to radar manufacturers, system integrators, both in the civil and military market. Our second pillar is services, where we dig into that 40 years of experience and sharing our knowledge on how we do measurements, how we do maintenance, how we can do fault finding on all kinds of CNS subsystems and complete systems. In this way of training, how to do procedures, maintenance, even certification and commissioning. And our third pillar is everything around manufacturing. If we can design and develop radar technology, we also want to build it against the highest standards. Our group is divided over 400 colleagues, distributed over 10 locations. We have our competence centers both in Europe, United States, and in the APAC region, and different IE entities closer to our customers for a closer collaboration and a day-to-day support to all of their projects. Besides the IE network, we have also a large network of sales partners supporting our sales and also good customer relations in areas where we don't have our own entities so far. Let us dig into the main topic today is the Radar Environment Simulator, the new released product of the RAS portfolio. We start with a short introduction, a little bit of history on where we came from with the product line, the use case, the who, the why, some benefits and capabilities, a sneak peek on the roadmap where we are now, and we will end up in the next coming months, years. And at the end of this presentation or this webinar, we close with a live software demonstration by Davey. So after this presentation, Davey will take over for a couple of minutes.
It's more like a sneak peek of what you can expect when using this REST system on the software side.
So what is the REST? The REST is the industry standard for IFF and SSR target simulation, and is designed for regulation compliance testing of secondary radar systems. How does it do it? He's doing that by RF simulation from 2,000 independent targets, both replies and ADSB. On top of that, we will generate also the interference and environment effects like fluid or reflections. And something important, but competitors sometimes like to input into the simulation is the antenna behavior, because that will have a huge effect on how the system and the test reacts on certain environment effects and how transponders work, and that's something quite important to take into account. The REST on itself is not a standalone product. It's taking into account or integrated into complete RAS product family or portfolio, taking into account those 40 years of testing and measurement experience to enhance even the features that we are presenting today in a larger scale. The REST will be delivered or proposed to our customer base in two variants: the civil configuration, mainly tailored to Eurocontrol and ICAO compliance testing, and the military variant where we can extend that portfolio to AIMS and standard Mode 5 testing.
Yeah, that includes like the whole encryption algorithms that are active in that military radar. And of course, the transponder needs to comply with that. So that's also a key factor in there.
So the integration of the REST is in RAS, which is actually a complete product portfolio for testing complete radar systems and all the subcomponents that are in the radar chain, both in field and lab environments. And it's not only tailored to just radar, it's a more complete portfolio for even communication, navigation, testing of subsystems and independent systems on itself. On this slide, I want to introduce a little bit of regulations that are just applicable to the REST and the secondary system that we intend to test. If you look into the complete portfolio for testing, like navigation, communication, and other radar systems, the list is much longer. But I want to introduce with this slide just to indicate that compliance testing and performance testing of a system is more than a 5-minute job, and it's quite complex, and it's a very skilled job, where the rest tries to simplify and support all the test engineers designing their test and make it a little bit easier to do the testing, check the performance, and collect all the evidence that's necessary to get that compliance certificate. A little bit of history on the RAS itself. It's already in the market since 1998, and currently we have more than 130 systems in operation. So in 1998, the first revision of this platform was released to the market, and over the past 25 years, we extended all the functionality and features depending on international regulations, user requirements, but also user development, where the market is going in the future. Ending up today with a brand new platform, taking all that history into account, taking all the strong points, and make us future-proof for new regulation and even more demanding user requirements.
Yeah, I think on this slide, I think the most important topics were listed. There are, of course, many more that were added into the past, like ADSB and stuff like that. But on this slide is only the general, the hot topics that were listed and that are really important for REST testing.
So what's important to notice from this 2.0 platform is that future-proofness, but also all the backwards compatibility, as already explained, testing and designing all the test cases for compliance certification is very hard takes a lot of time, a lot of effort, and we don't want our customers to start from scratch. So we take all the legacy information into account to make that transition to the new platform, but also for new users, make that transition to the new platform much easier and a relaxed transition. So why do we actually need REST? There are actually 3 use cases or typical use cases that we foresee the REST in supporting and develop for. And let us start with the birth of a secondary system. So we start with the system developers, the design engineers, who want to test the full capabilities against industry requirements, but even go beyond what's needed there to find out where the limits of their test design, where the faults in their design is, and test all those capabilities before they go into full production mode and full validation testing. After that, after system engineers, you have your system acceptance engineers who are entitled or have the burden to provide all the proof for compliance testing, provide all the procedures, all the test cases that they are needed for that certification, but also provide all the requirements and all the evidence during factory and site acceptance testing. This not only once, but every time they deliver a new system to a new customer with different requirements, the REST capabilities come in very handy because they can design test cases once and reuse many. So that repeatability is one of the core functions of the radar environment simulator. And at last, we have our test engineers who are responsible for regression testing and standard factory product testing to see that every system that runs from the production belt, our production area, is meeting all the requirements that are needed for that specific subsystem. They're also being supported by the REST if a component is being changed into a certain radar system due to repair or system change or update of the configuration and software. The REST will be there to support them to see what the impact is on performance and to see that the system is still meeting all the necessary requirements. The list for the benefits and capabilities could be much longer, so I had to choose. It was a very hard choice to select a few of them. Let's pick a few critical parts. With the new platform, we are able to enhance even more the realistic target environment simulator. So even compared to the previous platform, the new platform gives you a more accurate and a more realistic simulation in lab environment, which is a key point. We have enhanced bytes also here again to support all the test engineers, but also the design engineers to get as much as information during test phase design, during fault finding, during simulation. The more we can give feedback during those design phases and test phases in a faster way, it increases their performance and increase their efficiency, which in the end will reduce the cost of using the environment and testing their systems in the factory.
Yeah, and on top of that, the current system has very limited bytes. So with this enhancement, it will be very much clear what the REST is doing at any point in time, and that's very crucial for test capabilities.
Another key feature in the new platform is remote calibration to increase that functioning towards our customers. With the remote calibration, they will gain more system availability because the system doesn't have to transfer from their factory to the IE entities for calibration. So they save time and money for the shipment. And backwards compatibility is a key point that you will see popping up on almost every slide to gain that trust in the platform that's already the standard for since 1998. Even though the REST is built for RF simulation, we can close the loop, and that's a very attractive feature and make it complete product is the full data analysis side on the end. So we don't do any only simulation, we also can close the loop in providing the evidence to show and indicate that the radar is meeting all its performance. And that's a key change compared to competitors of the radar environment simulator. From that highlight, how does that now relate to actual functional testing? So the REST will simulate up to 2,000 independent transponders as they're defined by the ICAO regulations and extend up to Amendment 90. It will support all the generation or test cases that are defined in the new European MODES standard 4.0. It's not only delivering standard replies from transponders, but it's in overlay, it will also generate ADSB targets with all the newest features and all the newest requirements. Mode 5 is already discussed a few times in these slides, so that's not only civil, but also our military customers are happy to use the rest for their Mode 5 compliance testing against the latest STANAG and AIMS regulations. As already highlighted a little bit, it's not only RF simulation that's important, also the data link and the digital output simulation and testing is one of the key components during regulation and compliance testing. That's one of the assets that the rest will add compared to other simulators. And something that also is being neglected too many times is how the antenna design looks like. The antenna pattern, the design of it has a big influence on how the interrogator or a secondary system will react on the replies of a transponder, and that coexistence between external field or simulation and the antenna, it's a huge impact on performance and in set to work and in compliance testing. And in the end, we have a moving platform functionality because not every system is placed on a stationary ground plate. It can be also installed on moving platforms like ships or aircraft. Also, that is fully integrated into the rest, and we can simulate all those movements of those platforms and indicate how it will affect the performance of the system.
Yeah, this is typically done using agreed algorithms and models that are working inside this kind of moving platforms. So at least we can support the if we are still looking at the backwards compatibility, that we still support the current moving platform situations and protocols.
So how does the rest look like? So on the left-hand side, you will see a little bit of the front and the back. We have, as for the attendees who are known or familiar with the 1.0 platform, you will see immediately that we have increased connectivity both on RF level, but also on timing level, which is on the back of the system. Why do we have included all those extra connections and connectivity? Is to simplify the setup in factory, making the connection diagrams and the connection to the actual system much easier, more straightforward, and more less complex, because everything is now built or housed into one single unit. So the complete test bench is this one unit. Compared to the 1.0 platform, there were 3, 4, 5 units depending on the functionality testing. Now everything is included into one product. So the overall form factor is much smaller. It's 19-inch and also much lighter compared to the 1.0 platform. So you have increased functionality, smaller footprint, easier to connect. So there's only benefits of this new platform compared to the previous one.
And also on the front panel, you can see there is a small screen and a menu where you can do quick settings related to, let's say, IP address and stuff like that. So that's also configurable from the device itself, if not already done remotely. So that's also available.
The new device is connected over the network, so integration into automatic test bencher or third-party test benches makes it much easier also for that dry runs and regression testing of our customers in their factories.
Exactly.
The last slides on this theoretical presentation goes over the 3 main changed application compared to the previous platform. So for the new users, this will be less familiar, but for the ones that already have experience with the 1.0 platform, they will see what advantages we will have in this new platform compared to the original one. So the first one is the new improved antenna editor, which is still includes the classical LVA design, but it's already enhanced to future-proof. What we see in the market is a new IASA or non-rotating phased array type of antennas. So this antenna editor is being made compliant that you can also apply those antenna designs into the antenna editor and also later on apply that during simulation.
Yeah, so the new REST system is also capable, as you can see from this slide, that not only conventional LVAs can be simulated, so which typically required an azimuth encoder interface. We also implemented a kind of a, how you call it, like a point and shoot mechanism, where you don't have azimuth information all the time, so that not only azimuth configurations can be issued, but also time-based, which makes it very useful for point and shoot antennas. So not only looking at this continuously rotating, but looking at a specific azimuth, for example, separated in time, which is also one of the key functions that this new REST will handle.
Due to the extended functionality of the antenna editor, we understand that for some customers, a lot of parameters to be set can be overwhelming. So the application itself operates in two modes. What we call a basic mode, which is the classic mode for classic LVA, which is mostly used in civil applications at the moment, and then more advanced use where the user will have all the flexibility and all the parameters to its disposal to do complex antenna designs, as they've already said, non-rotating active antennas. To keep that separated from an advanced user or from a simple configuration for the antenna, we have decided to go for a 2-operation mode to make it easier for the user and the design engineer to operate.
Especially that backwards compatibility is very key for our customers. So we don't want to lose their existing scenarios and antenna patterns. So we need to be able to also simulate those, and that's very important.
Thank you. The main application that we have changed and upgraded according to the new regulations and also for the new platform is what we call the scenario generator, or the application that is intended for all the test case designs. Here is also the most and the uses the most largest changes being included. So it's a full graphical interface where the design engineer for the test cases have full control over designing their test cases, and he has full control over what kind of transponder, all the transponder settings that are defined in the ICAO Annex 10 regulation. They are incorporated into this application. So you have, as a test engineer, full control of every single bit that can be set and can be used. You can also define the type of target, for example, an F-16, a helicopter with all those credentials to be included, and define your test flight patterns, how fast a certain aircraft has to move, turn rates to test, for example, the tracking capability of a system. On top of just the targets and the flight movements, we can add events as also defined in the different regulations, and the influence of reflection or the environment can be added on top of that flight patterns. Again, backwards compatibility is key. So all your previous design test cases can be just imported into this new scenario generator and can be replayed with the new platform. So that's also very key. So you don't lose all the hard work you performed in the past. You can just upgrade and keep on working with what you have. So some slides to give an idea how fast and how large we increased the functionality of the scenario generator is we have a fast pattern definition to increase your efficiency in those test case designs. So the faster we can make your support you in correct test case design, the faster you're able to run and start doing your simulation and start testing. The same for the transponder. You have full functionality depending on the transponder type you have to use, you want to test with according to all the specifications and regulations that are needed. For the ones who have to design the transponder definition, they're going to have a lot of fun finding out what kind of settings and what kind of bits and bytes they can modify and can parameterize for every single test case.
Yeah, this tool, for example, if you can go back, Glenn, I'm not sure if you can do that. Yeah, so you can see this is one of a snapshot from the trajectory scenario generators aircraft and transponder database. In this case, we streamlined the whole procedures to set individual parameters using this software application. And also here you can switch between basic and advanced views to make sure that you're not getting lost in the whole bunch of a lot of transponder settings that are applicable for a secondary radar operational behavior. So it was a huge work to gather all these settings and parameters into a nice streamlined view. So that's what you can see here. Sorry.
So what's a very nice thing with the scenario generator and also the rest of the applications, that the bias they are also here to support all the design engineers. So if you make a setting which is incompatible with other settings and according to the regulation, the application will give you a warning that you have made an error, or let's say a mistake in your transponder design, which could result into a non-functional test case. So that's very keen, and it's a very huge advantage compared to the legacy platform, which is not supported there.
Yeah, during my software showcasing in a couple of minutes, I will also explain a bit more on these views. Yeah.
Already explained, you have full control over your aircraft definition, where you can, which will have an impact on which kind of patterns you can fly, and which kind of patterns you can design. So also here, full control by the user and by the test engineer to set those up. Also full control in your platform definition. So not every platform is based on a ground system standing still. It can be on a movable platform like an aircraft or a naval ship, which on the next slide, I have a short movie around. So as a design engineer, you have full control of all the movement like pitch, yaw, roll, and rotation of the platform, just to indicate. So you have that full control and simulate how fast and how much impact there will be of a certain movement, or the amplitude of a certain movement, the velocity that the rotation changes and direction changes will have on the system under test, and then you can test the limits of your system itself.
Yeah, this view shows how it is visualized in the 6 degree of freedom environment. It's not only, it doesn't stop here. So it means that if this moving platform is defined, also this movement data needs to be forwarded to the interrogator under test. So due to the network connectivity we have with this new REST system, it will also be easier. But of course, we also need a protocol or an ICD in order to transmit this moving data towards the interrogator under test. So it doesn't stop here. So it's just to give an example of the current way like naval platforms are configured using the REST system in this view.
Besides your flight patterns, your platform definition, transponder definition, you have full access to all the events that can be programmed according to the regulations. Again, of course, we always have to send back to the regulation. So depending on which kind of event you want to program, dynamically extra parameters come available. We have designed inside the application to have a clean and sleek overview of the parameters, which parameters you have to set for a certain event, just to help the design engineer to set the correct parameters for the correct event and don't have a crowded interface. So clean, sleek, and easy to configure. That's one of the goals.
Yeah,
for
this event definition editor, just to give some background information, by events, we actually mean things that happen during the scenario run, like you can observe in a real-time situation when the transponder changes its mode A code, switches on its SPI indicator, stuff like that, not only for CIV, but also for mode S. There is a quite extensive list of events that can happen. So we also did a major upgrade on those in order to make it more streamlined for the user to program such kind of events in your scenario using the same tool.
Similar for the reflector. So on top of your transponders, your targets, we can test the environment influence, like refraction processing. Those you can define into your test set and see how the system would react on reflections, and that it can properly mitigate those bad influence from a possible environment.
Yeah, so this is like programming some kind of reflection surfaces in the vicinity of the radar, which also result in extra reflections that you might want to test in your interrogator, in the radar interrogator.
The model definition option inside the target generator or scenario generator is also there for supporting all the test engineers, because the regulation mandates that during load models where we have to simulate a high load of targets, has to be distributed in a certain way and in certain areas. Instead of doing the manual design of those flight patterns and those distributions, we have included inside the application an automatic distribution model according to how it was written in those requirements and those regulations. And the test engineer only has to give in the radar specific parameters, and then the model automatically calculates the distribution and designs the scenario automatically for those test cases. Depending on the type of test you want to do, a different model can be applicable, and it's all user selectable in that graphical interface.
And this is all AMS4 focused. Yeah.
One of my functions I like the most is indeed the better byte. Even during the test cases, if there's something wrong designed during your synthesis or during your flight check, your flight pattern design, if there's something wrong, the application immediately warns the design engineer that there's something wrong in the design cases, and you don't end up with an unfunctional test case before you run it on the system, on the test. So everything should be green and fully functional when you compile it in the scenario generator. I think David also will show that into the live demo after this presentation.
Yeah, similar. So it all depends whether you make mistakes during the scenario run. The user will be informed by this, which was a huge limitation we had, that we need to adjust that. So if there are any scenario errors, the user will definitely be informed what is wrong, whether it's related to its trajectory path or transponder settings that are not compatible to each other. The user will be informed on this.
And the last upgraded application that we wanted to indicate, and I think David will have a little bit more demo on that than I can show on the slide, is the new improved control and monitoring to control the RES device itself, where we can define and upload the scenarios or the test case that we want to run. And then again, the test engineer has the full capability of making a combination of test cases, what we call a playlist, and then run that playlist once or in an endless loop to do regression testing. And also for every single run, the controller has full options to which kind of platform he wants to use, which antenna pattern he wants to use, and then to this using the same only define scenarios once, reuse many with different antenna patterns, with different platforms, so to increase your efficiency and time during testing, and less time on designing those test cases.
Yeah, well, it's not specifically in my demo, but I want to give some extra information on this already. Due to this new control and monitoring application, it will be possible to just load in the definition files that were created in the beginning, like the scenario and the antenna patterns definition file. Everything will be stored into a definition file. It can be loaded in here. So when it comes to a scenario replay, at the moment the res is busy, everything doesn't need to be pre-compiled. So that's one of also the major advantages that we will have with this new res system. It doesn't, when you want to make changes to a scenario, it is not really needed to always recompile the scenario again. So that's a key factor using this new control and monitoring tool, which just can handle definition files instead and stream the data live during over the network connection during the scenario replay.
And then the last thing that I wanted to include in the application is the analysis part. So it's not only the RF simulation part and the defining the test cases, it's also the analysis part. And there are just 2 slides on that. Is you have the high-level data analysis, which is included into our inventory tool, and the probability of PD and accuracy tool, which gives you just the standard and the high-level KPIs as mandated by the different regulations, like probability of detection, the accuracy, the biases, code validity. But what we have extra, and that's a game changer compared to competitors, is the full data link analysis, where you can do full interrogation and reply analysis for what you have defined into your test case, what the radar is interrogating, what the rest is replying, and on top of that, the 4th layer of what the radar is actually extracting from those simulations. And all those 4 layers can be matched in an interrogation reply analysis program and different applications to fully test and investigate all the bits and bytes of those data link protocols, fully covering the test engineers and providing them with the evidence and the proof to go for compliance and certification documentation and mandating. So this is one of a kind. This is quite unique into the test scene for testing secondary radar systems. So this is one of the key things, also part of the RES product, but also with the extension of that 40 years of radar testing and radar measurement. Measurement is key, and we have those detailed analysis tools. Then we are ending up almost with the last slides of this theoretical presentation. This is a sneak peek in the roadmap. So Q4 of this year, we will release the civil res to the market, so we can deliver them and to you by the end of this year. Q1 next year, we will try to release the military res, and beyond that, there are some capabilities or backwards compatibility functions that are left over. We will implement after Q1 next year, and of course, we are open to any customer customization, or we're open to see what the new regulations are coming out. Those will be planned and included into the new platform as they are being released. So a small recap of what we have seen so far is the RES is one of the most complete test benches for testing your SSR and IF radar system, both for the design engineers, acceptance engineers, and your regression testing. So we can do full compliance testing from the regulations in a lab environment. So you're not longer bound to traffic of opportunity. You don't have to wait for the perfect conditions when the correct aircraft are flying in there. No, everything can be tested under controlled circumstances and repeatable in your lab environment. And due to it's only one unit that can cover all the tests, it's a quite cost-effective product to support your regulation testing, but also your factory acceptance testing and production tests. In case you have more information or you need more information detailed than what we have presented today, feel free to reach out through our website or directly to our contact details. Or if you're in a country with our local entities, always reach out to our local partners. So for that, thank you very much for the technical part. I think now we can switch over to Davey for the software demo.
Yeah, well, I don't want to keep it too long, so I'm going to just switch my screen sharing on.
Guys, we've got both of the mics off if someone wants to switch their mic on. Okay, great.
Is my sharing on now? Okay.
Yeah, please.
Okay. Oh, okay, I'm sorry. That was my problem. Sorry.
Glenn, perhaps I can field some of these questions while we're getting that to work.
Okay, you guys should be shared by now.
No.
No.
Okay, that's better.
Yeah.
Okay, so now there's one thing before I just want to demo some newest software features that we have. With this new REST design also comes a new major update of the software and its suite of tools. We tried as much as we can to migrate all of the current tools that we have for the existing RES. And trust me, there were a lot of them. So for example, when you want to run a scenario on the current RES, there were a lot of tools like RES main control for mode 5, for ADSB, but also on the trajectory scenarios generator side, there were a lot of tools that our customers have to use, which might sometimes result in sometimes getting lost in which tool you need to use. So we try to improve that as much as possible into a more user-friendly experience, not only for the scenario generation tools, but also for the RES replay tools. One of these tools that we have merged into a single tool, which is the trajectory scenario generator, it will now handle all the different aspects of scenario generation, ranging from the start position of the targets. For example, if I switch to my target list here, if I zoom in on these targets, I can quickly select the target. All my information is available here, and I can put it wherever I want. The flight pattern, for example, can be displayed here. So there is a separate view specifically reserved for defining the trajectory of a target. Now, in this case, it's a very simple one. It just flies for 10 minutes, starting from a specific location. So yeah, it's quite a collection of tools that were all formed into one, also with specific views on the right. So mostly on the left, you can always find the control tools, and on the right, you can also see the viewing tools and the configuration tools. It doesn't stop there. So for example, for the target definition, there's also a view for the platform definition. In this case, I've put up a fixed platform, but there are also 3 other platforms in the scenario, which also is a big change because we can now also create scenarios for multiple platforms. Once we take this scenario definition into our control and monitoring tool, it will ask us which platform that the scenario needs to play against to. So if in the camp, for example, in this case, there are 3 platforms selected. So we have the same selection in our control and monitoring tools in order to make sure that we are simulating against the correct platform. This is one of the updates that we did. All these definitions that we can make from these tools are saved into a definition file. We opted currently for a JSON file, which makes it more readable for customers and also do diffing on them. So it's easier for them to see what the differences are between the 2 scenarios, or more or less. Yeah, if there are specific features required related to target generation platform, for example, the scenario modeler that Glenn extensively talked about is available from one of the menu tools. For example, here, in which I can simulate a scenario completely by just setting up a few parameters. For example, the peak target model is one of the newest models you can find in EMS 4.0 standard documentation. So you can even control where these sectors are. For example, this is just an example where you can define specific parameters, and then you can just generate a scenario by a single click. Also, if you're interested in this model, you can find also the documentation right here. So if I generate this scenario, for example, it doesn't take into account the platform, but I already set it up for this demo. So if I say yes, if I go to my target view, you can see that now I've just created a simple modeled scenario from the EMS specifications. And behind the tool is all the mathematics that calculates the complete scenario. So we just need to save this so we can replay it on in the RES control and monitoring tool, which just takes in this simple definition file, and then it just can start replaying this scenario. If there are any errors, you can see already if there is a light color, it typically means there are some warnings in this case. In this case, they're all static targets, so it's logical that there is a warning now because the targets are not actually flying. They just stand still for a number of time in seconds, and then they just don't move. So this is a quick sneak peek of what we can do with the software. I'm just mentioning one other thing before we can start jumping into the questions, because I can see there was a lot of questions coming in. We also updated the transponder databasing. As you can know from the current tool set, all data related to objects, whether these are aircraft or transponders, are stored into a database, and they can also be saved to a generic database file, which is like a full collection of all used objects and transponders located or specifically needed for any scenario you can think of. While the scenario itself only keeps a local version, a small set of this data into that local scenario. So this is just one of the features that we added. There are, of course, a lot more. I can talk more about this for maybe another extra hour, which we do not have at this moment. But I'm just highlighting a number of useful features that makes it easier for the customers to program scenarios into the RES. Let me see if I have another important things to say. I guess we still have a lot of, let's say, 30 minutes, so I think we can now jump to some questions, if that's okay. So
30 minutes is a bit ambitious, David. It was more like 10, 15. But anyway, we've got some questions in, so I'm going to go through them now. I hope you guys are up for this. We've got one here from Brenda from NAV Canada. Is this someone you know?
Give me a second. Have you signed from your end? Okay.
Can you hear me okay?
Yeah, I can hear you again.
Okay. All right. So I've got a question here from Brenda from NAV Canada. She would like to know if this has a capability to create mode interrogations to be tested with its impact on civilian radars. Mode 5, she's put there. So does this RES have a capability to create mode 5 interrogations so it can be tested, so its impact on civilian radar can be tested?
So, hi Brenda. No, the RES only doesn't make interrogations, it makes replies. So depending on the interrogation from the radar side, there we can provide the correct reply on it. So if you have a mode 5 interrogation, the RES will reply with a mode 5 information or content. So if you don't have the correct reply interrogation, we cannot generate the correct reply on that. So it doesn't generate replies out of itself. The only thing that we can generate out of itself is ADSB squitters.
Great. Okay. Anything to add to that, Davey, or is that answer the question as far as you know?
Yeah, that sounds reasonable. Although the hardware has capability to transmit or simulate an interrogator, its main focus is to generate replies. So that's the most key aspect of our RES system. Although the hardware should be able to do it, but just sending the interrogations at 1030 megahertz would be possible. But yeah, then the key is to combine it into a complete set. So
yeah.
Okay, great. Thanks, guys, for the answer there. So I'll move on to this next question from Bhavesh Patel. Bhavesh is asking, he's first of all saying that Res 1.0 will generate a response from a transponder across the defined sum B versus an ISLS setting of 4 dB or 9 dB, for example. Yep. So does Res version 2 behave the same, or is there a way to input an ISLS setting per transponder?
Yeah, well, that's a good question. In fact, our new REST system can handle that. So there is an opportunity to switch the transponder by using a parameter to make sure that it can also measure the difference between the P1 and the P3, the P1 and the P2 pulse, for example, if I just take an example of a Mo3A interrogation. So the REST is able to do that. So this means that also has a consequence that, for example, if you simulate a 360-degree antenna pattern, you could simulate like punch-throughs in your scenario and test on your interrogator side how he handles that. So yes, it will be supported. It is supported, yes.
Okay, great. Thank you, Davey. So there's another question. Sorry, I'm gonna shoot through these pretty quick because we've got several here. There's a question here, and I can see the question. Sorry, I'm talking a lot. I should just get on with it. But there's a question here from Peijan Shao, who says, asking, can you elaborate the capabilities you have in terms of testing PSR with MSSR, especially with AESA?
It doesn't matter too much with AESA. So what we have for capability of testing a primary system with a secondary system, there are two options. So if you have only a secondary interrogator, the REST will reply on RF to that interrogation from the secondary system, and simultaneously you can replay on LAN the primary detections that the primary system should detect to test sensor combining and see the complete tracking of those two systems. The second option is that you team up the radar environment simulator with our primary target generator, and then you can both simulate the same kind of test runs on RF on both the secondary side and the primary side. But then you team up the radar environment simulator with an extra simulator just specifically for the primary side for testing. And that's independent for which kind of antenna patterns you have.
Great, thanks, Glenn. So I'll move on to the next one swiftly. This is from Andre Beseda. They're asking, does new res have in-beam multipath simulation where antenna pattern is distorted? In-beam multipath simulation capabilities where the antenna pattern is distorted. I mean,
that's an interesting one. Yeah, we see multipath as a form of interference. So if Andre means that we are talking about fruit and all that stuff, currently there is no, also in the legacy res, there is no formula for multipath implemented. But we're open to modification and see how far we can get with this.
Okay, great. That sounds reasonable to me. He has written a follow-up question as well, so let's fire into that one. And you guys are doing great, by the way. It's very impressive knowledge. Does new res support a cluster operation functionality, i.e., can it simulate cluster controller or slave MSSR to check another MSSR which is working as a cluster controller?
Yeah, this is talking about the SCF function. So that's asterisk category 17, if I'm not mistaken. This is the system coordination function that there are specs for that, but currently in the industry, there is no specific tool to test this. We already noticed this. And so I believe, Glenn, correct me if I'm wrong, if it's a separate on the roadmap, or
it's a cluster testing. The cluster controller testing is something out of scope for the REST environment simulator itself. It's a separate application. But to answer his question on cluster testing, it's the same capabilities that we have in the current platform. Those are also migrated into the new platform. So if you want to see that we can do the similar kind of testing on the new one as in the old one, yeah, it is possible. But for full cluster controller testing, that's something out of scope for the RF simulator. That's something else.
I remember we had analysis tools for that, and we still support them. So,
yeah, those are.
But for the simulation, we currently don't have a solution, if I'm correct.
Okay, great. Thanks, guys. So we've got about 5 minutes left. We'll probably get through 3 or 4 more questions, but let me just let everyone know that if we don't get to the questions, then the guys will follow up afterwards. We record everything, so they can follow up with email answers back.
Yeah,
so,
sure.
So if you have any questions, feel free to post them now. We will pick them up after the webinar's finished. So anyway, let's move on. We're back onto mode 5. Eric Genet would like to know, is mode 5 capability available to non-military staff, ANSPs?
No, the mode 5 capabilities are only available in the military configuration. So they are free to buy the military configuration, but only the mode 5 capabilities will only be implemented in that revision or that variant.
And I believe that answers Brenda's follow-up question on as well. Yeah, on mode 5. So we can go on to Philippe Hitz, who is asking regarding EMS 4 version 4 for software RAS 8, is it possible to calculate EMS 4.0 requirements, for example, PD per aircraft, long gap mode C, etc.?
I think we have to. Yeah, it's stationed in AMS 4, so we have to test that for sure. So it will be updated, to my opinion.
So Philip, that has to be integrated in the new revision of the PDN accuracy tool. Yeah, those KPIs has to be calculated.
Yeah, it's part of EMS, so we have to do it anyway.
Okay, great, thanks. So this next question is from Sergei Sandu, who is asking, can this tool be used to verify multilateration systems?
In the end, yes, it's on the roadmap to implement, Sergey, but currently it's not implemented. The main focus of the first release this end of this year is the AMS 4.0 civil radar testing, followed by mode 5 testing for military system, and then beyond that we will do what we call function extension and system extension to different markets like multilateration and WAM. But at the moment, in the current release this year, it will not be fully present for multilateration testing.
Yeah, but technically it should be feasible to do it. Yeah,
the system has that capabilities. Yeah. There's no technical or observation or obligation in the device itself. It's just software and firmware to be added and functionality to be included into the device.
Great, thank you. Okay, so this question here is from Manuel Yaguez. Sorry for murdering your surname. Can you elaborate a bit more about encoder signal architecture?
Hi, Manuel. It's quite similar to the current platform. So what we will able to input and to output is encoder signal like classical ACP on both TTL level, single-ended and differential. But also we can include or slave on an absolute encoder input from your design. So basically that's all possible for different interrogators. So it's classical, differential, or TTL, both input output, and on the input side also an absolute encoder. And if I remember correctly, it's an SSI interface for that absolute encoder.
Great. So this next question, just a couple to go. It looks like we're going to get through them all, which is fantastic. This is a question from Claudio from Leonardo. He's asking regarding the features of EMS 4.0, please. Oh, sorry, phase overlay function is implemented in the res?
So, yes, absolutely.
So Claudio, yes, that's implemented both on the SSR target replies and as on the ADSB replies according to DO 260C. So yeah, that's full
in the software you can it's a part of EMS4. So in BDS 10, sorry for my confusion, BDS 10, there were new bits added that signifies the capability of the transponder to support phase overlay both in Mode S and extended squitter. So yes, it can technically do that, and it will do that. Yes.
Great. Final question on this list here, another one from Manuel. He's interested to know if is it possible to emulate a drift in one of them, while you maintain the other okay? Does that make sense?
So my assumption, Manuel, that's back on your encoder output. In the first revision of the software, we intend to have both encoder outputs identical. We are able to simulate bad encoders. That's part of the functionality list that we have foreseen into the roadmap. But keep one okay, make one good one and one bad one. That's something that we have. It's not included yet, but it's something that we can put on our extension list and on the feature list to implement. But
right.
The functionality, the possibility is there, but it's not implemented at the moment.
Fantastic. Look at that. We've done all the questions and the presentation within the hour. So
That's cool.
Fantastic. Yeah, I know. Fantastic Q&A session there, guys, and fantastic presentation. I'm really impressed with the depth of knowledge and the engagement of the audience. It's been really interesting. Do you want to finish with any closing remarks at all? Or?
No, we thank you for having the privilege to talk about this. And it was an informative 1 hour, I think.
So Ben, thank you for hosting this. For all the attendees, I don't see anyone on the screen, so I don't know, but I hope you enjoyed this 1 hour session. And the only thing I can say, if you're interested, if you have more questions, feel free to reach out to our local entities, but also straight to our website or straight to the team here in Belgium. And we are happy to support and to answer all the questions that are still open, that's still wondering in your mind. We're here to help you and provide more information.
Yes, please do follow up with any of us. Just to let everyone know that you will receive a link after the presentation is finished to watch the recording. Also, Glenn and Davey has said contact them if you want the presentation in digital format. They'll email it across to you. Okay, all right. Thank you, everyone, again, and thanks for your attention. And have a great day wherever you are.
Yes, same for you, and all the